Okay, so this video is to do with question 4, the summary question 4 on page 37 of the OCR AS textbook. So there's 3 parts to it. We're just going to look at A and B in this video. So the first part, part A, says balance the equation. So I've written the equation out here. You can see we had 4 oxygens on the left to begin with, 3 oxygens on the right. So we've got 1 more on the left compared to the right. The easiest thing to do here is just put a half in front of the O2. So this becomes 1 oxygen now altogether here instead of 2. So now we've got 3 oxygens on the left, 3 on the right, 1 sulfur on the left, 1 on the right. That's balanced. Then part B says state the volumes of sulfur dioxide and oxygen at room temperature and pressure. So that room temperature and pressure tell us that we need to use the molar volume equation that will produce 180 centimeters cubed of sulfur trioxide. So the first thing we do, we're given a volume of that sulfur trioxide. So the first thing is to work out moles of that. Now in the question, the volume was in centimeters cubed. So we're going to use 24,000 centimeters cubed as molar volume instead of 24 decimeters cubed because we need to keep those units consistent. So this is the equation for molar volume if you weren't sure about it. Moles equals volume over molar volume, which we have here. So 180 over 24,000. And we get 7.5 times 10 to the minus 3. Write that in. Okay, so from our balanced equation, we can see we've got 1 lot, so 1 molar ratio of the sulfur dioxide and 1 lot of the sulfur dioxide. So these 2 moles are equal. So whatever the number of moles is for the trioxide, it's going to be the same as the dioxide because it's a 1-to-1 ratio. So to get the volume of the sulfur dioxide, all we do is rearrange the equation, this one, for volume, and do moles that we've just worked out, because it's the same ratio, so it's the same number, 1-to-1, times 24,000 to give us the volume in centimeters cubed. So I'll just pop that in my calculator, times 24,000, and we get 180 centimeters cubed. Then for oxygen, you can see we've got 1 lot of this, 1 lot of this, and we've got half as much oxygen. So it's a 1 to 0.5 to 1 ratio. So the moles we've worked out for the sulfur trioxide, we just divide by 2 to get the moles of oxygen. So I'll do that now. 7.5 times 10 to the minus 3 divided by 2 is 3.75 times 10 to the minus 3. That's our moles of oxygen. Now we're going to use those moles to work out the volume of oxygen. And times by molar volume, which is 24,000, and that will give us a volume in centimeters cubed. Ninety centimeters cubed. And a quick check to see if our answers make sense. From the equation, you can see we've got half as much oxygen compared to the SO2, the sulfur dioxide, and you can see that we only need half as much oxygen compared to SO2 to produce 180 centimeter cubed of the sulfur trioxide, which makes sense because of the ratios. Hope that was helpful. Bye.